Hello, algebra students. Mr. Lawrence here with the review for Unit 3. Now, I just finished grading your quizzes, and some of you got a little bit of work to do before this test. I hope you're preparing. I told you I'd post this Saturday night, and it's actually Saturday morning. It's going to be a little bit of a longer video because it is a review one, but I will be up by no later than noon, I would suspect. All right. By the way, I got to mention, I'm really proud of Leah Bazan. She kicked some serious butt on that last quiz. Way to go, Leah. I am exceptionally proud of you. I know you have it in you, and I know if you keep doing your best, you are going to get one of the highest grades in the class, not just on a test, but you can do that all year long. All right, so let's get down to this. Oh, it looks like I'm making some random marks here. Let's get rid of those. First thing we have to know is how to name our polynomials. And remember, we have different types. We have linear ones, which means the highest power is 1. So for example, like 5x, there's a 1 there. Quadratic, where the second power is, or the highest power is 2, like a 5x squared plus 3x. Yeah, there's an x to the first power, but the highest power is 2. Okay. Cubic means the highest power is 3. So if I had 5x cubed plus 7, that would be a cubic example. And then quartic means the highest power is 4. So 5x to the fourth plus 3x cubed. The highest power is 4th, so it's quartic. Okay? Then we need to know how many terms there actually are. If there's 1, it's called a monomial. Okay? Bi if there's 2 terms. Tri if there's 3. And poly if there's more than 3. Okay. Uh, and you just add a nomial or meal onto the end, depending on which prefix you're using. So, for example, if I had this 3x cubed minus 2x plus 7, well, highest power of 3, so this is cubic, and there's 1, 2, 3 terms, so it's a trinomial. So therefore, this is a cubic trinomial. All right, why don't you go ahead and pause the video and see if you can name these 4. See if you can do it. When you're ready, unpause and see if you get my answers. Okay, here are my answers. You can see I've got a cubic binomial. Cubic highest power is 3, 2 terms. A quadratic trinomial, 3 terms. That's where the trinomial comes in, and the highest power is 2, so it's quadratic. This is a linear monomial. Highest power is 1, and there's 1 term. And then the highest power is 4. And there's several terms, more than 3, 4 to be specific. It's a quartic polynomial. All right, we've got some distributing and foiling problems here. Now, I really would like you to do these on your own. Do them on a sheet of paper, do them in your notebook, and then, unpause the video and look for my answers. If you're still watching at this point, I'm assuming you're ready to see my answers. Here they come. On this one here, I have to distribute a negative, right? We've done this before. And so I will have a negative 5x plus 7. Remember, distributing a negative is like distributing a negative 1, multiplying everything inside the quantity by negative 1. All right, this one here, I'm going to distribute the 3x to all 3 terms. And 3x times 5x is 15x cubed. 3x times 2x is 6x squared. And 3x times negative 1, negative 3x. All right, here is a FOIL problem. We have to do first, outer, inner, last. My firsts are going to get me 25x squared. My outers are going to get me positive 35x. My inners are going to get me a negative 35x. And my last are going to get me a negative 49. Now remember, I have to combine like terms, but these two terms will cancel out, leaving me with a 25x squared minus 49. I did that kind of slow. I know Mr. Weekly is probably going to criticize me. If you wanted to, I could do it much faster. Did it slow just for you, Austin. Didn't want you to fall behind. All right, here's another FOIL problem just to prove I can do it faster. I will. I've got 9x squared. I've got a minus 12x and a plus 4. If you didn't get that answer, check your outers and inners. You got a minus 6x and a minus 6x. That's where my minus 12 is coming from. 3x squared times 3x squared, 9x squared. And negative 2 times negative 2, positive 4. All right, this one here will fool you. I'll put some of these on a test like this. I'll put a problem, at least one. It's a FOIL problem. Two options. One, you can go like this, 2x plus 1 times 2x plus 1. All right. Or if you know how to do it quickly, go ahead and do it quickly, but make sure you get a middle term. 4x squared plus 4x plus 1. If you were thinking that the answer was 4x squared plus 1, you are incorrect. You need to FOIL. It's a FOIL problem in disguise. All right, here we go. Firsts are going to give me 12x squared. My outers are going to give me a negative 48x. My inners are going to give me a positive 6x. And my lasts are going to give me a negative 24. I'm going to combine like terms. The 12x squared and the negative 24 will stay the same. And I believe I'm going to have a negative 42x when I combine these two. And there you go. All right, we're on to factoring and solving. And again, if you can do these on your own, you go ahead and do them and then come back and watch the video to make sure I've got them or you've got them right. Well, make sure I've got them right too. If I make a mistake, it's possible. All right, GCF. Why do you suppose we learned GCF first? It's the first type of factoring you should try. You should always try to GCF first. It'll make things easier. Okay, so let's see here. I'm looking and I see a GCF. I think I have a GCF of 8 and x cubed. So I'm going to divide both quantities or both terms by 8x cubed. But remember, I can't just divide out. I'm actually undistributing it. I'm pulling that out. And what's left inside the quantity is the result of the division problem. So it looks like I'm going to have 2x squared. And over here, they cancel out, right? Which means there's a minus 1 there. Don't make that mistake. A lot of kids throw it away, say, hey, they're gone. There's nothing there. No, division cancels to 1, not to 0. All right, on this one, it looks like my GCF of my numbers, my coefficients, is going to be a 6. Remember, always find the GCF of your coefficients, then find the GCF of your x's. Looks like I have, here, let's do this so it's not so sloppy. Okay, I've got x to the 7th, x to the 6th, and x to the 9th. Okay, looks like it's going to be an x to the 6th, right? Remember the shortcut, it's always the least exponent. The variable with the least exponent is what they have in common. All right, the y's, got a y there, a y squared, and a y to the 7th. And so I will have a y as a part of my GCF. Okay. And then finally my z's, I have a z to the 9th, a z to the 8th, and a z to the 5th, which means z to the 5th is a part of my GCF. All right, so I'm going to pull that out. I'm going to get a 6x to the 6th, y, z to the 5th. And what's left inside will be the result of my division problems. Well, the 6's cancel, the y's cancel. X to the 7th divided by x to the 6th is x. Z to the 9th over z to the 5th is z to the 4th. Okay, plus, this is going to get a 2. X to the 6 are gone. So we're going to get a y, and I'm going to get a z cubed. Then minus, going to get a 4, an x cubed, a y to the 6th, and the z to the 5th cancel in this particular problem. All right, that is factoring by the GCF. Now, it's best when we built it into other things. Now, I didn't put any specific grouping problems on here because I taught you to factor the trinomials by grouping. So I will explain it in there. Okay, so here's trinomials and binomials, and sometimes we're going to be solving them. And so I'm going to do problem number 1, or better yet, pause the video and try to do problems 1, 2, 3, and 4. See if you can do them and then unpause the video. You've got to constantly be challenging yourself. Now, some of you had some problems with trinomials, like you don't know how to factor them. I saw one kid, and I won't name them in the video because I don't want to embarrass them, but I hope they realize who they are. on problem 2, they try to do something like this. And then they tried to factor this and tell me equals 15. And you know what? It's not going to work. It's not going to work. It might work in a special case, and I can show you that special case later, but it's not going to work. This is quadratic. We need to be solving them by factoring. Okay, no, it's not a solving problem, but go ahead and pause the video. See what you can do with it. All right, if you're ready to see the solutions, here we go. Now, I'm going to do this first one the long way. I'm going to do it by grouping. So I'm going to need factors of 8. I need 2 factors of 8 that add up to be 9. Well, I got 1 and 8 and 2 and 4. Those are the only factors of 8. How do I know I'm going to add them? Because the 8 is positive, and I'm going to get a positive 9. Well, it looks like the problem is going to be 1 plus 8. So I'm going to rewrite this as x squared plus x plus 8x plus 8. And now I'm going to group. And I know on a problem like this, many of you go, man, this is way too long to do this. I know that, but there's some of your classmates that don't get grouping yet, and they don't see the shortcuts. So we'll go ahead and do it this way on some of the problems, and I'll do it quicker on others. Okay, so it looks like I'm going to GCF this first quantity, which is an x, and I'll be left with an x plus 1. Here, my GCF is an 8. When I factor out the 8, I'm left with an x plus 1. Now notice I have 2 multiplication problems. I have x times x plus 1 and 8 times x plus 1. Did I repeat a factor? Yeah, I sure did. I said x plus 1 both times. That means it's common, which means I can factor it out. I can factor out an x plus 1. What's left here if I divide by x plus 1? Well, x is left. What's left here if I divide by x plus 1? Well, an 8. There you go. It's completely factored. Again, that is the long way, but it's a good way to demonstrate grouping. Would you like to say hi, James? Shout hi really loud. Go ahead. Oh, my son's shaking his head. He must have got stage fright. He came out to help me with the video. Okay, so on a problem like this one, we need to multiply the 10 by the 15, right? So we get 150. Now, I'm going to subtract my factors of 150. How do I know subtract? 15 is negative. To get a negative 19. Now, it's not really super intuitive to me, but here's what I'm going to do. Okay, now I know a lot of you don't know prime factorization. Of course, you can list out all the factors, but I'm going to take 10 times 15, and I'm going to break them down into their prime factors. 2 times 5, and this will be 3 times 5, right? And because of the commutative property, I can move things around, and I'm looking for 2 factors of 15 that subtract to get 19. And look at this, I've got this 5 and a 5 here, and 5 times 5 is 25, right? And here I have 2 and 3, and that's 6. Now 25 minus 6 is 19. Hold bus, I need a negative 19. So I don't want 25 minus 6, I want 6 minus 25. Okay, so I'm going to rewrite this problem as 10x squared plus 6x minus 25x minus 15, and that of course is going to equal 0. Now I'm ready to group. Always grab the sign when I group on that third term, put a plus in between the quantities. Okay, so I GCF. Looks like I'm going to pull out a 2x. I'm going to be left with a 5x plus 3. Here I'm going to pull out a negative 5. Going to be left with a 5x plus 3. Did you hear me repeat myself? Yeah, I said 5x plus 3 both times. I'm going to pull out a 5x plus 3. The leftovers are 2x minus a 5 right there. Now it says equals 0, so I have to solve. Now you can't just plug a number in. Remember, I saw very few people on the quiz actually show this amount of work. And if you can do it in your head, it's awesome. But if you can't do it in your head and you're just sticking a number in, then it just doesn't make any sense. It's not a very smart thing to do. So I'm not sure why you would choose to just not do the technique I showed you. I mean, great if you can do it in your head, I don't care, but if you can't, it's just foolish to do it wrong. So I solve the linear equation. Oh, by the way, there's a couple of you out there that don't know how to solve linear equations, and that's unacceptable. And if you don't fix that problem like yesterday, then you won't be staying in honors. I cannot send a kid to honors geometry that doesn't know how to solve a linear equation. Okay, so there's one of my answers. Now with this one, I'm going to add 5 to both sides, and then 2x is going to equal 5 divided by 2. X is going to equal 5 over 2, or 2.5. So there's two answers. So maybe I'll present it this way. X will equal -3/5 or 5/2. Okay, so let's see here. I'm going to rearrange my page 1 second. Okay, sorry about that. I decided to give myself more room. I was running into um, myself. So anyway, okay, now remember, sometimes the problems have more than one type of factoring built into them. Like first of all, this problem 3 here, it has a GCF hide in there. It's an x. I'm going to pull the x out, be left with a 6x squared plus a 7x minus a 5. Now, I've got to factor further inside of here. Okay, now this x out front, I'm not going to combine them with the stuff I do. Some of you are doing that on the quiz. I'm not sure why. Um, well, I can see why, but then you were making other mistakes and you should have refactored them out. I'm not going to combine this x with anybody else uh, because I'll have to just factor them out again later. So I'm going to put that little highlighter there to remind me, don't do anything with him. He's just come along for the ride. So I'm going to look in here and I'm going to multiply 6 times 5 and I'm going to get 30. Okay, I'm going to need two factors of 30 that subtract to get 7. Well, that was pretty obvious. How about 10 and 3? So I'm going to rewrite this as x, and I'm going to change it to a bracket there because I'm going to work inside here. And then I'm going to have 6x squared minus 3x plus 10x minus 5. Now, some of you might be thinking you would have written the 10x first, and that's fine. I chose to do it this way because I won't have to factor out a negative. And I liked my coefficients going larger to smaller, larger to smaller. Positive, negative, positive, negative. Had I done it the other way, it would have gone smaller, larger, and it would have been positive, positive. This one would have gone smaller, larger, negative, negative. I'd have to factor out the negative. It's 6 of one, half a dozen of the other. It's not wrong to do it the way you might have been thinking of. Okay, but I'm just trying to show you what I'm thinking. Grab that sign, stick a plus in there. And so now, still have this x out front. I'm not going to combine them with the GCF from this quantity. Okay, I'm not going to do it. So I pull out a 3x, and I'm left with a 2x minus a 1. Here I'm going to pull out a 5, and I'm going to be left with a 2x minus a 1. It just dawned on me the mistake some of you were making. When you combined these two, you were saying, hey, it's x times 3x. No, this x has to be multiplied by all the terms inside the quantity. So it would have to be multiplied by the 3x, the 2x minus 1, the 5, and this 2x minus 1. So you can't just combine these two here. That's the mistake you were making. I wasn't realizing it till just now. Okay, let me get rid of that circle there. Oops, didn't want to get rid of that part. There we go. I think that's what was missing. Okay, so now inside here, I still have an x. I'm going to be able to drop this bracket because I'm going to take this 2x minus 1 and factor them out. And then I'm going to go have left over 3x plus 5. Now when I go to solve this, there's going to be 3 answers. Why are there going to be 3 answers? Because there's 3 quantities. Do you see all 3 quantities? I do. Here, I'll highlight them for you. Okay, the obvious quantities are this one and this one, but this is also a quantity. So what you need to do is set all 3 of those quantities equal to 0, x equals 0, and solve. 2x minus 1 equals 0 and solve. 3x plus 5 equals 0 and solve. Okay, I'm going to add 1 to each side. 2x equals 1, x equals 1 half. I subtract 5. 3x equals negative 5, divide by 3, divide by 3. X will equal negative 5 thirds. So my three answers are that x could equal 0, 1 half, or negative 5 thirds. Any one of those numbers substituted in for x into the original problem will cause the whole equation to go to 0. All right. I'm going to erase that so it's out of my way for work purposes. And here, problem number 4. Looks like I got a GCF hiding in there. And so I'm going to pull out that x, and then I'm going to have a 9x squared minus a 24x plus a 16. Now, I mentioned special patterns. Look, I don't want to multiply 9 times 16 and break down the factors. What's it going to be, 254, I think? That's going to be a rough one to do, but if I notice that this is a perfect square and its square root is 3x, and this is a perfect square, so square root is 4. If I multiply these two together, I get 12x, and if I double it, I get 24x. This is the perfect square trinomial I've told you about. You don't have to do all the work. You can do x times 3x minus 4, and then times 3x minus 4. Perfect square trinomials. The square roots go here and here. Since there's a plus in the back, this sign shows up twice. Negative, negative. If you're not sure, FOIL it. There were very few people that FOILed to check their work. Okay, so once more, we have 3 quantities, but in this case, we only have 2 unique quantities, so I only have to do x equals 0 and 3x minus 4 equals 0. It would be silly to write this down again. I'm going to get the same answer. It's the same problem, so I'm not going to waste my time doing that. So I'm going to add 4 to both sides. 3x equals 4. Divide by 3, divide by 3. X is going to equal 4 thirds. So the answers are x equals 0 and 4 thirds. There you go. All right, moving right along. Hold on a second. Giving myself a little more room to work there. Okay. Problem number 5. That's a Roman numeral 5. I see a GCF hiding. I see a 7x. I'm going to pull out a 7x. I'm going to be left with an x squared minus 4 equals 0. Now I'm going to pretend like I don't know that that's a special pattern, and I'm going to do it the grouping method. So I have 4, and I need 2 factors of 4 that subtract to get 0. Well, that would be 2 minus 2. All right, so 7x times x squared plus 2x minus 2x minus 4. 7x stays out front. I'll have a 2x times, well, I'm show you what I'm doing here, sorry. Getting ahead of myself, I'm grouping. Right, and I'm GCFing this first quantity to get an x plus 1. And I'm going to pull out a negative 2 to get an x. Oop, I have a mistake, don't I? Sorry, let me back this up. The GCF of this first quantity is only x. And so I'll have an x plus 2 left. Then I'll pull out a negative 2 and have an x plus 2 left. Okay, now the 7x is out front, and I'm going to be able to drop the bracket now, and I'll have an x plus 2 as a quantity, and then an x minus 2 would be left over. All right, so 7x equals 0, x plus 2 equals 0, and x minus 2 equals 0. And so x could equal 0, 2, or negative 2. Right? Okay. Now, and I did that one the long way just to demonstrate grouping. When I talk about special patterns, I'll do that. All right, this one here, this has no solution. There's no way to factor it. If you were thinking of factors like this, please FOIL it and you'll see it does not match. If you were thinking that, oh, I know this has to be a positive, then FOIL it. It will not match. Okay, there is no solution to this problem. This part of the problem is prime. The correct answer is no solution because it says equals 0. All right, let's get on with the special patterns. Okay, we're going to talk about those special patterns. The first two are actually the difference of perfect squares. How do I know? I have a perfect square minus a perfect square. These are the difference of perfect squares. It happens when a perfect square is being subtracted from a perfect square. Now, some of you are going to try to tell me that this isn't the case on negative 25x squared plus 9, and that negative 25x squared isn't a perfect square. Well, what would happen if I rewrote it this way? Don't I have a perfect square minus a perfect square? I sure do. Okay, so it's going to factor the same way. So, um, this first one, I know the square root is x. I know the square root is 6. It's going to factor as x plus 6 and x minus 6. Thank you. And there you go. I'm done. I'm not asked to solve it. I'm just asked to factor it. There you go. Piece of cake. Right in front of you. Sorry, my daughter was talking to me. All right, now this one here, you know what, I am going to rewrite it this way. And I've got a perfect square minus a perfect square. Well, the square root of 9 is 3. The square root of 25 is 5x. Well, 25x squared, that is. So I'm going to get a 3 plus 5x and a 3 minus a 5x. And there we go. Oops, I'm not done. Silly me. It says equals, so I have to solve it. 3 minus 5x equals 0. Well, now I'll solve both parts. I'll go 3 plus 5x equals 0. Subtracting 3 from both sides will get me 5x equals negative 3. Dividing by 5 will get me x equals negative 3/5. Okay, over here I'll have 3 minus 5x equals 0. Subtracting 3 from both sides, I'll get a negative 5x equals negative 3. Dividing by negative 5, I'll get x equals positive 3/5. And so your answer will be x equals negative 3/5 or positive 3/5. And there you go. All right, now trinomials have special patterns too. They're called perfect square trinomials. I'm going to erase some of my work here because it's getting in my way. And that happens when the first term, like 49x squared, is a perfect square. It sure is. The second term is, or excuse me, the third term is a perfect square when it's written in descending order. If I multiply together, I get 35x, and if I double it, I get 70x. See how it matches? Here's how it factors. I'll have a 7x and a 5 and a 7x and a 5. Now, all I have to do is pay attention to my signs. There's a plus in the back. It's the Wendy's double stack. The negative shows up twice. Bam! Now it equals 0, so I do have to solve, but they're the same quantity, so I won't solve them both. I'll get the same answer. That would be silly. 5/7 will be the answer. All right, this one here is also a perfect square trinomial. It's not a solving problem, so I just have to factor it. And I'm going to see x squared square root is x. Square root of 81 is 9. If I multiply together, I get 9 times 2. I sure get 18x. It goes x and 9, x and 9. Plus in the back, it's the Wendy's double stack. Boom. Too easy. All right, did you notice on the difference of squares problems, you got one of each. You got a plus and a minus, but on the perfect square trinomials, you get the same sign twice, whether both be negative or both positive. All right, for story problems, I'm just going to do the story problems off of your review sheet. Okay, so problem 31. says if you square the lesser of two consecutive odd numbers, I'm going to stop right there. I need two odd numbers, two consecutive odd numbers. Well, the first one, I'm going to let x equal the first consecutive odd integer. Okay? Then this next consecutive would have to be x plus 2, right? Because don't odds go 1, 3, 5, 7, right? So I'm going plus 2 every time. Okay, so it's x plus 2 is the second consecutive odd integer. All right, I got to go back to the story now. And it says if you square the lesser of those. So I'm going to need to square the lesser. Well, the smaller one would be x. I'm going to do x squared. Okay. It will be the same as, well, that sounds like an equal sign to me, increasing 4 times the second. So I need 4 times the second, but I have to increase it by 13. And now I'm ready to solve this. I'm ready to solve this problem. It says, what are the consecutive odd integers? Now, I don't like to solve trinomials or quadratic trinomials unless they equal 0. So I'm going to make this equal 0. I'm going to subtract 4x from both sides and subtract 13 from both sides. Okay, so I'm going to get x squared minus 4x minus 13 equals 0. Okay, so I'm going to do this the shortcut factoring way. I'm going to have x and x, and I feel like I have a mistake here. Yeah, because 13 is prime. Hold on a second. Did I miss something in the problem? Hold on one second. Yes, I do have a mistake. It's a silly one. Remember, I had to square the first one, x squared. But then I had to increase the second one, and I wrote down 4x. The second number isn't x, it's x plus 2. I need to do 4 times the quantity of x plus 2. And then I need to increase it by 13. I'm so sorry about that mistake. Hopefully you caught it. Fortunately, we caught it right away. So now, before I start subtracting stuff, I'm going to distribute here and get 4x plus 8 plus 13. And I'm going to combine like terms. So I have x squared plus 4 equals 4x plus 21. There we go. That looks a little bit better. Now I'm ready to subtract 4x from both sides and minus 21 from both sides. And so I'll be left with x squared minus 4x minus 21, and that'll equal 0. Now, again, just to reiterate, the mistake I made was that the first number is x. Squaring it, well, geez, I just square it, right, which is x squared. But the second number is x plus 2. So if I want to multiply by 4, I have to do 4 times the quantity of x plus 2. Okay, so here I'm ready to factor. I need 2 factors of 21 that subtract to get negative 4. Well, how about a 3 minus a 7? So I could go x minus 7, x squared minus 7x plus 3x minus 21. That'll equal 0. And I will, okay, take out a GCF, get an x minus 7, take out a, oops, wrong symbol there. Oh, take out a 3, get an x minus 7. Okay, and I'll have an x minus 7 times an x plus 3, and that'll equal 0. Okay, so my choices are x equals 7, in which case x plus 2 must be 9, or x could equal negative 3, in which case x plus 2 would equal negative 1. So there's 2 sets of answers. All right, I'm going to do one more story problem, the other one from the review sheet. And let's see what it says. A garden is 5 yards by 12 yards. So I'm going to draw my garden. Oh, and I'm really good at drawing rectangles. Watch this. Isn't that a beautiful rectangle, ladies and gentlemen? Yes, I am so good at this. It's 5 yards by 12 yards. You know, I happen to know that that's going to be 60 yards squared. I don't think I'm going to use that information, but it's good to know. Sometimes I will. Now, I think the problem says something about increasing it by the same amount on both sides. All right, well, if I got to increase it by the same amount on both sides, this will become 5 plus x, and this will become 12 plus x. The new area is going to be 260 yards squared. Okay, what are the dimensions of the new garden? Well, in other words, I got to find out what x is. If I can find out what x is, I can add it to 5, add it to 12, and I'll know my new dimensions. Well, there's a FOIL problem. To do the area of a rectangle, don't I multiply the base times the height? And if you're wondering why I chose to switch the order, I just used the commutative property, and I did it because I can factor faster in my head when it's x plus 5 than I can when it's 5 plus x. You might think that's silly, but I've had years of training and practice with this, and I've always done it that way, and so that way is much quicker for me, and that's why I can beat Austin so quickly when we do stuff. Anyway, sorry, couldn't resist that, Austin. Just a small joke there. All right, so I'm going to FOIL x squared plus 17x plus 60 equals 260. And I find it ironic. It's not really relevant to the problem, but check this out here. Did you notice that the area of this was 60 and that we ended up with a 60 in there? Yeah, I don't think that's a coincidence. Anyway, I'm not going to explore that right now, but always looking for new patterns, new things to realize. I'm going to subtract 260 from each side because quadratics need to be set to 0 to solve. X squared plus 17x minus 200, that'll equal 0. Now, I'm going to need factors of 200, okay? I need factors of 200 that subtract to get 17. You know what? I'm not going to list all the factors. I'm going to try the prime factorization. I'm going to break 200 down to 20 times 10, and I'm going to break 10 down into 2 times 5, and then I'm going to break 20 down into 2 times 2 times 5. Okay, so I'm looking for a way to multiply, subtract, and get 17. Well, 5 times 5 is 25, right? That gets me 25. And then I'd be forced to multiply 2. Oh, I should change colors on that. 2, 2, and 2, which would get me 8. I have 25 minus 8. Oh, look at that, it's 17. So I can go x squared minus 8x plus 25x minus 200. That'll equal 0. And then I will group. So I'm going to pull out an x, be left with an x minus 8. Pull out a 25 and be left with an x minus 8. Yeah. Well, then when I factor again, I'm going to get x minus 8 times x plus 25. Now, when solving these, I'm going to get two answers. I'm going to get x equals 8 from the first quantity, but I'll also get x equals negative 25. This one here does not make sense. Watch. If I put negative 25 in for x, I get 5 minus 25. Then this equals negative 20. How can you have a length or a width that is negative 20 yards long? You can't. It's not possible. The only time you can have a negative distance is if the negative is indicating direction. So this negative 20 won't make sense. So x must be 8. So 5 plus 8 is 13. And 12 plus 8 is 20. And so therefore the new dimensions, the new garden, is 13 yards by 20 yards. All right, that's the video. That's the longest one I think I've ever done, but you've got several days to watch it. Good luck on your test. Goodbye, everybody.